Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 3, 2026, just 2 days ago. It introduces 3DIMO, a framework that achieves a Frechet video distance of 297 by distilling driving frames into implicit motion tokens, significantly outperforming current state-of-the-art methods like mimic motion. The paper is titled 3D-Aware Implicit Motion Control for View Adaptive Human Video Generation. And, as we'll see later, the resulting flexibility in camera control is really impressive. Figure 1 illustrates exactly what this looks like in practice. In each block, the top row shows a driving video that provides the source motion, like the man gesturing in the top left. Beneath that, the model generates completely new videos of a different character. Here, a woman in a living room performing those same actions. What stands out is the text control. Prompts like camera rotates in a circular path, direct the viewpoint dynamically, while the character faithfully reenacts the original motion. Figure 2 details the architecture, starting with the training framework on the left. A driving video feeds into the yellow motion encoder at the bottom, which uses separate paths for the body and hands to capture fine details. These motion tokens are injected into the purple diffusion transformer blocks via cross-attention. Crucially, the top right panel illustrates view-rich supervision, where the model learns to reproduce motion across different camera angles. Finally, the bottom right shows how inference combines these motion cues with text-driven camera control. So Table 1 presents the quantitative evidence, pitting the model against baselines like Animate Anyone and Uni3 circa. On the left side, under the standard metrics, the bottom row shows that 3DIMO achieves the best scores for LPIPS and FID, which indicates superior visual quality. Crucially, it hits an F versus D of 297.4, significantly outperforming the next best method. The user study on the right confirms this, with human raters giving it the highest scores for both 3D plausibility and overall naturalness. While the table showed the numbers, Figure 4 provides a visual comparison of these artifacts in action. The grid starts with the reference and driving inputs on the left. In the middle row, look at the red box on the Animate Anyone result. The hands get tangled because the model lacks depth awareness. Moving to the bottom row, the yellow boxes reveal how methods like MT versus Crafter distort the legs during a complex squat. By contrast, the final column demonstrates that 3DIMO handles these challenges cleanly, maintaining accurate structure. Wrapping up, the key insight here is that implicit learning often beats explicit geometric constraints for video generation. By training on view-rich data rather than relying on rigid skeletons, 3DIMO achieves smoother motion and flexible camera control. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.